Okay, I guess it's time.
Is it?
Yes.
I think it is. All right, so
I guess you're doing the first bit, as usual.
oh, I am?
Oh, you're the agenda, aren't you? And I'm doing document status.
Oh, that works. Oh, so, do you want to stand up?
No.
Okay, let me just get the jabber room going first.
Okay, people, welcome to the six-man session. We're going to start in a minute or two, so please find your seats.
So, welcome to Six Man. Beautiful Prague. So I'll do the, well, here's Note Well, which I'm not sure, I can't read those letters. I hope you can. The new Note Well slide from the Secretariat. So we now have a Jabber scribe and a minute taker.
Yes. So Barbara has volunteered to do the minutes, and Michael is doing the Jabber scribing.
Many thanks.
And he's now going to give instructions.
Yes, and please make sure that I can see your badge and make sure that it's not obscured on either side. So put the subway card in the middle. Otherwise, you will be sternly talked to when you walk up to the mic. Thank you.
Thank you. And the blue sheets should be circulating, I think.
Yep.
So please sign them. Yep. So this is the agenda for today. We have a set of working group drafts, active individual drafts, and some new individual drafts. So I think we should have enough time in the agenda for active discussions. I'm sure the RFC 24 or 4291 BIS will be an active discussion given the mailing list discussion. Any comments on the agenda? And Oli will do document status.
Right. So since IETF 98, we have published 3 new documents. Perhaps the most important ones are 8200 and 8201, which is the, yes. And good work, Bob, for guiding those through their somewhat dangerous waters at times. And we have advanced to Internet Standard also in place, 4443 and 3596, so that's the DNS and ICMP options. And we have parked 4291 BIS, as we could get no consensus in. So Suresh, I don't know, we have one more slide on this if you want to talk. Well, you can talk about it now or later. Yeah, go on. Yeah. Waiting for write-up, we have the Max RA draft. That's yours, Suresh. That's ready to advance, right? Thank you. And we have 3 active working group documents, the node requirements on the agenda. The RSRA refresh has expired, so I think we need a note from the authors there if they're still interested in progressing that draft. And then the segment routing header document, which is not on the agenda this IETF. Yeah, perhaps you should, since you're there, Suresh, why don't you talk to 4291 BIS?
Okay, Suresh Krishnan. So the reason I send this back to the working group, right, is like I was looking at all the stuff that happened in IETF last call, and I didn't see any easy resolutions to the concerns raised. So there's like kind of, it's a very polarized community, like if I put it mildly. And there's not like any wordsmithing that's going to fix this. So there needs to be probably some kind of fundamental rethinking in the working group on how we want to go forward before it comes back. And that's why I sent it back instead of trying to like get like somebody Bob to sit down and fix some text, right? Like, and I think there are like a lot of reasonable text suggestions, but I think we don't have a shared understanding of like what all these terms mean, just to start off with. And I don't want to see this back until like those things are resolved. So I really would like the working group to try to solve this, take the time and solve something here. And I hopefully don't have to call consensus, but if I have to, I will, right? So that's why I'm kind of keeping off from the active discussion on this. But I really would hope that the working group can converge on something. And if you need like more time on this, like if you want to do an interim somewhere, like it's all like ideas that are open for this, like to make progress on this. Yeah.
Yeah, thank you. And we have, so Bob has a session on this afterwards, and we can certainly continue this discussion at that point. We are done with all our goals and milestones. I'm sure we can figure out some new ones if we put our minds to it. But currently we are done. So at some point we need to have that discussion, if we both on charter and goals and milestones. Okay, so that was the introduction from the chairs. I have a 5-minute slot now to just talk about where we are with the V6 core specifications to Internet standard. So here's pretty much the summary. Those 1, 2, 3, 4 documents that I spoke about earlier, which have now all been advanced to Internet standard, I think that is IS 87 and 88, is that right? Okay, so we got three I's. Okay. Then a privacy extensions document, which we didn't advance, and the 4291, which is parked. So we have to think about the next steps. So we have currently still in draft standard is the addressing architecture, privacy extensions, neighbor discovery, and Slack, which is probably quite a big piece of work. The V6 over PPP, and in the original plan we made, we also talked about advancing, the V6, the other V6 over foo documents, probably in particular IPv6 over Ethernet. Any views in the room of where we want to go with this work? Do we want to continue? Have we been so scarred by the 4 documents that we've done that we want to wait a few years and see if we'll recover? Because we have, at least in my experience, we have, opening old wounds might not be the most pleasant of activities. But at least, at least in theory, we should be doing something with these draft documents. But Lee, please.
Lee Howard. Well, first of all, I think you have the RC numbers swapped for the first 2 items there.
Oh, yes, they are. My apologies.
Which is pathetic that I can instantly recognize that, and I'm sorry to everyone for doing that.
Maybe that's the solution to figuring out this impasse.
I'd like to make a request of the chairs. Can we add this slide as the last item today? Since we're going to be discussing some of these, it may be that we decide just to abandon or give up on some of these things, and then come back and decide whether, if we decide, hey, no, we're not going to make any changes to addressing architecture, maybe we don't need to add that as a milestone.
Right.
So
yeah.
Can we ask these questions in an hour and a half?
Yep. Eric?
Yeah, Eric Klein. Do 4861 and 62 have to go together?
No.
So we could just do, for example, 4861.
Yeah.
Because that is like a rather non-optional part of the protocol. So.
Yeah. Okay, so, but I think we'll follow Lee's proposal and or suggestion, and then come back to these and see if we can find some conclusion on it at the end of this session. So I think with that, Bob, you have the pleasure of doing the addressing architecture.
Good. See if this works. So, we pretty much talked about this. Since the document was parked, I submitted based on the discussion, submitted 2 new drafts, 8 and 9. And so I'm going to talk about the changes. Well, let me just do it. I pressed the right button. So these are I think the smaller changes. Removed the instructions to IANA about the port number assignment. IANA fixed the problem in March. And I redid, like I did in the other 2 documents, the changes since 4291 to have both the draft by draft changes, which will get removed by the RFC editor, and then a single section, which is the actual summary of the changes, not because several of the things went both ways if you look at the per draft changes. And then I also removed the short paragraph about manual configuration that was added in 08, because based on some comments, I don't think it actually added any value. So actually, why don't we do the others first, and then we'll come back to this, because I think it will generate the most discussion. So there were 2 changes related to prefixes. The first was to add a note to section 2, explaining that prefix is used in different contexts in IPv6. Whether it's on link, and it's used for creating addresses. So if there are comments on this change, well, you know where the mic is. And then the other prefix change, which I think was suggested, which I think makes sense, is to talk about how prefix is used. This is intended to resolve the questions about on link and not on link and so forth, without getting into infinite. It's not trying to replicate what's in 5942, but I think it's a good summary and then points to the document that talks about it in more detail. Okay, so this is the text I came up with based on the discussion about /64. I've seen there's some support for it on the list. There's some other text that's been proposed. I think this is the big tussle we're having is about this text. I think this text does talk about interface identifiers are 64 bits except and lists the exceptions. And so I think this meets a lot of the things that have caused this discussion, but I don't know that there is consensus around this text, or if there can be a consensus around variations on this. But this is where I'm expecting people to get up to the mic.
There's a little internet draft that kind of speaks to this, but when you look at the actual reality of Slack as it is documented and other things and all the other documents, that it's not interface identifiers are 64 bits led. except if on Wednesdays, Tuesdays, and in fact, there are some cases where you probably want 64, and classless v6 makes that pretty clear. And for the rest, there's no need for this restriction. There's no actual need. It's just back to the history of TLA, NLA, and trying to tell operators who are the enemy of IPv6 what to do. And for those who don't know me, you might remember, you should know that, our network was the first to deploy v6 commercially in '97, right? It's not that I'm a v6 hater, it's that I'm a v6 lover, and this stuff makes it painful. Okay? And Slack is not restricted to 64 bits. I might do 60 bits. I might do 72 bits. And it works. The thing that you don't want to do with Slack is have it so small that privacy addresses don't have enough space for entropy. And the simple little stupid classless v6 document points that out. So this is a little bit of an inverse. And I think the classless v6 says it a little more clearly.
Okay.
Lee Howard, I think that you are accurately describing the way the internet is running now. We have running code on this, and I'm not clear that we have consensus other than this. I wonder if the crux of the against this language, I wonder if the crux of the argument is over the word manually, and specially would be a different, a better way to describe it. That if you have other special configurations, but the default configuration is 64-bit. But I'm happy with this text and would love to see it move forward.
Lorenzo Coliti, just to provide the other side of the...
Who are you?
Lorenzo Coliti. You can find me on the attendees list. Just to provide the other side of that tussle, I think, as a, we build host operating systems, and I find that, this is very close to what we have always had written in the standards. It's been very close to what we've had for 20 years. And I think really the value of this number, this 64-bit number, is reserved for, really it's reserved for future use. It's reserved for, 20 years from now, we'll figure out something new. And this stuff has got to be powering the internet for 3, 4, 5 decades from now. And we don't have a pressing need to relax this restriction. It's not clear to me that we have that we have some use cases that would benefit from it immediately. I just don't see them, and so I don't see a big need for this. In fact, I would even remove the by exceptions defined in standards track documents. We don't even need to say that, because by definition, a standards track document can update this document. And in fact, I would prefer to see that text gone.
Thank you.
Job Snijders, NTT Communications. What I would like to see in the total body of work is that in no way hardware vendors are allowed to take shortcuts and, for instance, say we only support /64 because of hardware limitations or reasons. I do see value in many cases to use /64. Let's call it the majority of cases. I just would really hate it to happen that some vendor at some point says this prefix length will not work with our hardware, and that's because IETF specified it this way. We've seen this in the past. It causes pain. So whatever we end up doing, we should not allow vendors to enforce the /64.
So just to clarify, so you don't think this text meets that requirement?
Well, because it focuses on /64 and it then, as an example, lists 127, what happens to the things in between? So one possible solution would be to remove this from the document. So there is no /64 references in this particular document. but each protocol that requires /64 or requires something else specifies it themselves. Another method to ensure that vendors adhere to any length will work is to explicitly state so.
Well, I mean, there is other text in the document that does say that, for example, routing should work with any prefix length.
That's routing, right?
Pardon?
And
I mean, it's not on the slide, but it's in, well, it's been in, I think I was 7, 8, and 9, that there is, that, you know, so this text is now in the in the section about interface IDs, which is, I think, where it belongs. But in the section about unicast addresses, there is, we could pull it up, there is text that already says that, you know, IPv6 routing should work with any prefix length.
then what is the value of this?
Well, because it's, for some of the reasons I think other people said, it's about interface IDs, but you raised the issue of whether you wanted to make sure that, and I agree with you, that we want the hardware to work with any prefix length. And so, but I think that would be driven by the text in the unicast section, not this.
Perhaps it would be simpler if then this paragraph is just removed.
Okay, well, I hear you.
Thank you.
Jordi Palet. I basically agree with what Lorenzo said, and in addition to that, I think it's perfectly normal in many other standards to have exceptions. So I don't think there is anything wrong having an exception here. Furthermore, I actually think that RFC 6164 is broken. I mean, I will really advocate, it's a different topic, but I will really advocate for /64 always, okay? Thank you.
Okay.
Janenko, as an operator, I do see value in restricting interface ID to /64 because I see problems which could be created if you start allowing to have interfaces ID of variable lengths. And again, as I +1 to what Lorenzo said, I cannot see what problem we would solve by allowing variable lengths, right? So I do believe we need to keep it /64 unless there are clear defined exceptions like point-to-point links, yeah. Because I think we open a door for problem in future. I have spent too much time in my life discussing should these subnets be /27 or /28 or 27 or /24 and so on, right? I think it was a progress, make an interface ID always /64. We should keep it like that.
Thank you.
Fernando, I think that any specific value, no matter whether that's 64 or anything else, I don't think that would belong to an architecture document. I mean, that doesn't mean that I'm in favor of one value or another, but I think an architecture document, that wouldn't be the place for setting a specific value. Now, with respect to the specific value, I personally think, besides that, it's like side comment, I think that when you specify values such as this, that allows vendors to assume that that value will always be the case. So if eventually at some point you want to relax that, there's going to be a lot of code that will break.
Thank you.
Hi, James Widyat, Nest Labs. I'd like to follow up to something Lorenzo said about specifically this phrase about or when defined by a standard track document. I believe I'm the guy that proposed that phrase. And I believe that my motivation for proposing it was in the hopes that it would help ameliorate a controversy, end the controversy by establishing a compromise that people could accept, and then we could move forward. I don't believe that compromise has been honored, and I agree with Lorenzo that removing this text should be, I mean, that's what we should do. It was put there for reasons that I don't believe make any sense anymore, so I'm in favor of taking it out. Thanks.
Okay. I mean, it is stating something that's true without saying it, but on the other hand, I don't think it does any harm.
Well, I don't think it helped.
Well,
So,
Obviously hasn't helped.
so Michael Abramson, So the whole manually configured here, is there other references that, so if a system goes in and configures statically an address, is this manual configuration?
It's a fair question.
Because
I mean,
this is a use case that most people do. Is this, so we have automatic in this context, which I think is the device itself, chooses something. If a system or human chooses something and configures it, is that manual configuration? Okay. Administrative configure works for me. I just so I don't know what the rest of the document says.
Could be a different word.
Yeah.
Yes.
So I think we should figure out a better word than manual, considering that there's a lot of people with IPAMs and they'll set static addresses by configuration.
Okay.
Yeah, Lorenzo Colletti, I think I really don't like that text exceptions defined in standards track documents. There's lots of those documents, and I think 6-man has in the charter, it has a special review responsibility and I think power that, it may request that any specification that affects the internet standards needs to be reviewed in this working group. Maybe we could use that process here, because I think we will, I would at least want to say here, if we do want to allow exceptions defined in standards track documents, that such exceptions consider the best practices written down in RFC 7934, right? So if my new IPv6 over foo text, because really we're only talking about a new link layer here. If my new IPv6 over, I don't know, like USB cable standard says, well, I only really need, 5 IIDs, and so we're going to pick 120. The same arguments that we've been having here apply in that case, like pretty much identically. And we would want to have that discussion to avoid sort of ending up with situations that then can't be extended.
Thank you.
Thomas Eckert. Yeah, so in Anima, we do have a solution where we're, automatically creating, tens of thousands of internal subnets in devices, which, for efficiency of routing would have to have a fairly long mask so that we can scale it. Right now, it's between, 96 and 127. And listening to this conversation here, I think that it's perfectly valid to, have reviews for any of these things. And I'm also, having this fear of unknown, things that come in the future that we're not aware of. So anything that helps in the text to make sure that, the people in the know who understand all the IETF processes know must happen, like you can write a standard that overrides this, or, if you establish something that, you think is a good practice, should be documented in best practice. I don't think it's a bad thing to write that down, even if it's replication of some, crazy documents that exist. But an operator would read this. He wouldn't read all the process documents that makes it clear to him, what the best processes are. So I think, whether it's standards track, BCP, right? If you do something different than this, right? Here are the forms on how you bring it to the IETF. I think that helps.
Thank you.
Randy Bush, IJ. I agree with Lorenzo. As he said in Chicago, that you want to change this, should be standards track JOC document. Certainly agree. That's why the classless IPv6 draft is a standards track draft.
Any other comments?
That's actually a good point, right? Do we want like, would we want a document such as the classless IPv6 draft to be able to change this text without formally updating 4291? Would we? I wouldn't, right? I mean, it's just in direct conflict, right? And so specifically, I think they should say, unless this document is updated.
Yeah, that would be fine with me. I think that's the sort of the intent by this words, but.
So, was that your last Well, Suresh is coming, so we have a set of next steps, right?
Yes.
Yeah, so Lorenzo, like it's going to happen, right? Like, so if you're going to change this, like somebody would like actually catch it and say like put an updates tag on it and bring it over here for sure, right? It's going to happen. But the point, like kind of like nobody talked about is like, it's not clear what an IID means for a DHCP v6 address. Like we haven't had the conversation yet, right? Like, so like when Randy says like, oh, I want to do DHCP v6 with foo and get an IID, I have no idea what an IID means for a DHCP v6 address, for example, right? Until we have that common understanding in the working group, I don't think we're going to make progress. Like I think we are having like a lot of good discussions, but there's like some very basic stuff like Jinmay's draft, like, you know, kind of started on like pulling on the threads to try and nail down something. But I think we need to make more progress to have everybody on the same page on what we're talking about when we talk about IIDs. So that's just my request, like to go forward with this.
Thank you. Christian?
Christian Ritema. I know I should know better than stop just watching this interesting debate, but the one thing that strikes me is that a lot of the motivation for moving that boundary is about defining large customer networks. I mean, if I hear the argument that about managing large customer networks, if I hear the arguments on both sides.
Yeah, stay closer to the mic.
If I hear the argument in both sides, I mean the one argument that's very strong on the hey, we ought to be able to do variability, etc., is assuming that your ISP or your provider gives to the consumer network a /64, which we know it will because there's so much legacy that if it gives something else, it's going to be constrained by, I mean, your support line will explode, so you're not going to do that. But the problem is that suppose it gives you a /64 and you want to have a complex home network, what do you do? Now, you could do many things. One thing you might do, which is kind of the assumption in the classless draft, is that you will have multiple segments, each of which have their own prefix and are configured. That's one assumption. But that's by no means the only possibility or necessarily the best possibility. What I don't see is an effort to get a consensus architecture on these large customer networks. If we add a consensus like that says, okay, we have this problem of large consumer networks, we have a way that they should be, I mean, meeting some requirements that I don't particularly know, then we might get a consensus on a way to do that, and the changes in addressing would eventually follow that consensus if there is one. In the absence of that, I doubt that we can ever converge.
So, at least to put that in my words, to make it clear that the edges get an adequate amount of address space so they can organize it the way they choose?
That's true, but what I would really like to see is a case study that says, okay, how would we do that exactly?
A problem statement, perhaps?
Maybe, yes.
We have that in the
Could I persuade you to work on a document like that?
In my vast free time without any revenues?
Sorry?
In my vast, if I get a sponsor, maybe, but.
I would help. Thank you.
Eric Klein. I believe on the mailing list there was a call for people who want to eliminate a bunch of this text to sort of provide a problem statement as to what actually is the difficulty with vendors and relationship to IIDs. I have not seen one, but perhaps I've not read every email on the list, or have not been participant to every discussion. So perhaps a problem statement about the problems that this causes might help clarify the direction we need to go.
Thank you. Randy?
Randy Bush, IJ. I have sympathy with Christian's problem. And there are other areas in the IETF.
Also a little closer to the mic.
Sorry. I have sympathy with Christian's expression of the problem, but it is actually being looked at in other areas like HomeNet. The problem to me is that what will happen is if I give them a 64 instead of, for instance, a 60 with PD, is what they're going to do isn't subnet. What they're going to do is NAT. Right? We have done more to promote NATs than, it's just tragic. And so 64 bits is probably a little long for a LAN. Layer 2 just doesn't do well above 59 bits. That was sarcastic, by the way. And we have to make it so it works a little better without promoting NATs.
Yeah, I mean, in some ways, my take on this, if I had to go back, had we done it where interface IDs, the length, if they were 48 bits long, and you had, say, bits before that to create subnets, I suspect that sort of makes sense to me, but I think I'm pretty convinced that we would be having the same discussion regardless of what that boundary was.
Bingo. The problem is what we're trying to do is embed in the address architecture a way of telling operators how they should run networks. There are two problems with that. It doesn't work socially. The operators had to dig out of the same mess in CIDR 20 years ago as we are today, and we're relearning all the same lessons. And there's a built-in assumption that the operators will do something wrong. And instead of how can we make it easier to do things well and right? The upsell instead of the restrictions that you then have to work around yourself, et cetera, et cetera. They probably won't have the guts to stand up here today, but I was talking to people who do IPv6 training not last week, week before now, and they said it's just getting more and more difficult and more complex to explain to people how to run a V6 network. And that's a tragedy. And we've brought it on ourselves.
Lorenzo Curidi, I think I agree with you, Bob. No matter which number we pick, there's going to be an argument. And I think, we've got the hosts on one side that would like to maintain innovation and would like to be able to avoid doing that. And then you've got operators on the other side who say, well, they have the need to assign whatever length is appropriate for them. For the HomeNet, for the extending the network at the edges discussion, we have guidance on that in HomeNet. It says don't assign just a 64. And, if people ignore that, then, whatever number we pick, it's going to be the same. Right? We say, well, okay, now we move the boundary to 80. That's fine. Now my host will accept an 80. Here's an 80. Have a nice day. So what do I do with that?
Right.
So I think, that's, I don't think we should even just go there, right? We have if we don't have a boundary, then we'll basically lapse back into IPv4 where the boundary is 128. And I think there's just no point in that, really. So we have guidance on that case. It's not a problem statement. We have IETF consensus on that. It's been published as an RFC. It's called the HomeNet architecture, and it says don't hound out only a 64. And it's supported by RIR policy, and it's supported by operational reality as well, right? So the RIR policies are assuming that every site gets a 56. So I don't see what the problem is here. There's plenty of space in a 56 for a home network.
Lee Howard, I think Lorenzo just made the point. Lee Howard, I think Lorenzo just made the point that I was going to make, except that I think the RIR policies allow for up to /48 to home network.
Hi, Tal Mizrahi, Marvell. I work for a chip vendor. So as an implementer, first of all, it's important for me to know whether the IID is 64 bits long or not. But it's also important to know how to optimize the implementation. That is, even if the implementation supports arbitrary length IIDs, still you need to know whether the system works optimally for 64 bits or for arbitrary lengths. So the way I read this text right now is the IID can have any length, but the implementation should typically be optimized for 64-bit IIDs. That's at least the way I understand it, and correct me if I'm wrong.
Certainly not interface ID is longer than 64 bits.
Right.
Though if we're not careful, we could write it in a way that would be possible too, which I don't think is what anyone wants.
Right, but my point was that the...
Sorry?
My point was that specifically the number 64 should be the point that is used for optimization. Thanks.
Hi there, John Brzezowski. So honestly, I've kind of been ignoring this thread on the list largely for a variety of reasons, which we can talk about later. But the thing that is, the conversation that Mike got me thinking about is, you need to be very careful about the water that you tread in right now, right? We have very explicit benefits that we've been able to leverage as part of, how the addressing architecture has been put in place thus far. Routing optimizations, tables, things that are amongst a very short list of things that people view very positively about IPv6, right? For example, changing this, right, making it longer, for example, could have a significant upstream impact, right?
So making which longer?
Making the
prefix,
making the interface identifier smaller, for example, would have pretty significant side effects, right? On the flip side, as much as we've talked about this for years here, right? Oh, hey, give everybody a 56 or whatever by default. Many other operators in the room will tell you that there have been many cases where that happens, where it breaks the customer, right? I still get devices that show up like 3 months ago that advertise a PIO with a 56 value in it, right? Not okay, right? It doesn't work, right? And you, Bob, as one of my customers, have a pretty good, I think, customer experience because we've taken a very conservative approach to make sure that we don't screw you, right? Right, and that's important.
I
right?
appreciate that.
Well, and I need you to remember that, dude. Right, I need you to remember that when we're talking about stuff like this because we've taken great care to do that to make sure that you don't have a shitty experience, right? And I think the changes that we make here, we have to be very mindful about those, right? Because they will have side effects. People will read all these things out of context, and next thing you know, you're not going to have such a great experience, right? So, peace.
Tolle Eckert. So.
Closer to the mic, please.
So I think this discussion provides a lot of good insight of, the pros and cons, and, I don't see any of that being written up, and I don't think as an ops group you have the, excuse of, oh, it's just a standard and we don't want to explain why. So it would be really good if, more of these things of justifying where we stand in the text.
So I don't think we have a consensus on this text. I think the most constructive thing I heard in this discussion is to try to write down, not for this, but in a separate document, what essentially we're trying to accomplish. And because everything is about reading between, this discussion is about reading between the lines and, 4 sentences. So I think if we were to write a document like that, and if we could talk about it in more depth and get consensus on that, then we could probably figure out what to put in this document. So,
yeah.
So get some volunteers to help write a draft like that. talk to me afterwards.
Randy Bush, IIJ, we foolishly thought we did.
Well, I don't think it covers all of the things that were discussed here. Maybe it could be in that document, but...
Then let's improve it.
It could.
Draft Bourbaki classless IPv6.0.0.txt.
You'll find it on the data tracker 6-man documents page.
Lorenzo Coliti, yeah, please put a problem statement in that. Lorenzo Coliti, please put a problem statement of that in that draft in the form of stuff that needs to be solved. Saying we had a problem in IPv4 in the 90s and CIDR is obviously the best solution for everything and so we should do it is not a problem statement. It is a proposal for a solution, but it is not a problem statement. Specifically, the question that I have never seen answered to any degree of completeness is, what can we do with smaller or rather longer prefixes that we can't do with a 64-bit prefix? The answers I've heard so far are defend against ND cache attacks, but that's trivial. You just don't forward those packets. And number two, I've heard extending the network at the edge. And I've heard several comments here to the effect that that won't work because it'll just move the boundary. So yes, I think if we want to take on this work, we need a problem statement, but draft Bourbaki is not a problem statement at the moment.
Barbara, have the last word, please.
Barbara Stark. I keep hearing that if we allow for longer prefixes, operators will, hand out the longer and longer and longer prefixes. Is there any evidence that operators will do this? I mean, because this is pure speculation, as far as I'm concerned, that has no evidence.
The evidence is that a number of prefix operators are handing out prefixes of the 64, which is the maximum length right now. So, and you think that if we change the minimum length to some other number, there won't be some operators that do that? Well, Randy says they think that you're telling them what to do. Well, I mean, there needs to be an agreement between the network and the hosts of some form, right?
I'm sorry, I just have to say that if you heard what John said, if you make the longer prefixes, it's going to cause problems in the access network and beyond.
To the regard of Job Snyder's NTT, I think you raised an interesting question. Is there evidence that telco operators will screw over their customers? And there are two sides to it. Yes, there are telco operators that, yes. I mean, there are good companies and bad companies. Sorry. There are companies that do hold the interests of their customers at heart and adhere to good suggestions, like give them ample of space, and there are the ones that don't. If I recall IPv4 history in the Netherlands, when we started out with DSL and dial-in, and everybody would get tons of IPv4 space until those pools started running dry. And the reason we nowadays have basically one IP address per connection is, I think originally it started with scarcity, which doesn't apply in IPv6. So I'm actually quite optimistic that companies may assign ample of IP space, provided that there's clear documentation that suggests to assign them ample of space. And I think there is a ton of that documentation. So I'm not that worried that we'll end up with just one address per connection.
Christian Wiedemer. I think that we really need the problem statement, and I do not think that the existing classless draft is the problem statement. The things that it does not cover are things, for example, like the dynamics of, the game theory of address allocation and what can happen. And I'm not saying that because I'm entirely sure that it will happen in a bad way, but it could. I mean, we have seen previous things like that. We also have to have, on the other side, the existence of legacy, which is part of the problem. I mean, there's a bunch of systems, like say Windows 7, for example.
A little closer to the mic.
There are a bunch of deployed systems, an example being Windows 7, that are not going to be updated. I mean, that part of the code in Windows 7 is not going to be updated for another 10 years, at which point the machine will be obsolete. So you can be pretty sure that for the next 10 years or so, an operator that handles a network that has a prefix smaller than 64-bit is going to have a ton of customer support issues. So if you handle 64-bit, yeah, 64. No. It depends on a bunch of legacy equipment, legacy routers, things like that. Okay, so there will be customer issues, definitely. So given that, I really believe that A, the document that we have, I mean, the Class S document is a solution document, not so much a problem statement. And that B, we do need a problem statement.
Thank you. So I think we're going to need to.
Yes, we have extended this session quite. We had some, but let's run through the queue and we'll end with you, Jen. But feel free to go, Randy, if you.
Jen Linkova, I just like to point out that there is a documentation which recommends a subnet size, which should be allowed to cite, and we still see it's being violated. So I do not think just documenting and telling operators what to do helps, right? So we do see evidence of operators doing something which is not recommended. That's why.
Into the mic.
Okay, I wanted to say that we do see that despite having documentation and recommendation for prefix lengths, which should be handed out to customers, operators do something not exactly recommended. So I am on the side of this discussion who believes that if we allow them to make it shorter, I mean, they give customers less addresses, they will as soon as we allow this. So.
Okay, thank you. So I think as Suresh said early in this session, is that we need to develop a common understanding of what it would take to get this document out of parked state. I think there's no indication in this room today that it isn't going to continue to be parked. Hopefully we're not going to collect parking tickets for every day, but I'm not quite sure what the path forward here is going to be. Time heals all wounds, perhaps, but let's see if we can develop some more work around problem statements, more common understanding of where we want to go with this and what problems we want to solve. Perhaps we should encourage more work on extending the what we call permissionless extension on the edge of the network, if we can come up with better technologies there. But this is just going to be an ongoing itch to scratch, I believe. I don't know, Suresh, if you want to have some last comments on this.
Suresh Krishnan. So as I said before, like if you want like some high bandwidth thing, maybe an interim would be useful just for this. And if you want to do it, let's get it done. Like, I don't know, either virtual or like, somewhere like if Lorenzo and Randy can co-host like something in Japan. I don't know, maybe like something like that would be good because we are all at the IETF, but we all have like a lot of things to do and it's very hard to find time to do just this one thing. So maybe something a bit more focused would help because getting all the people together and talk about just this thing might be helpful because I don't think we have spent like a lot of time understanding each other. Like that's my view.
Thank you. Lorenzo and then Randy.
In Bologna? Oh. Okay. I know anyone there. In Bologna? Okay. Food's good in Tokyo. You can find some good Italian. Lorenzo Coliti, Yeah, I agree with that. I think maybe we should try to find. There are problems that we have that we don't know how to solve, like extending the network. Like, what do I do with a VM inside a VM inside a VM? Like, one thing that we're facing with the Android emulator conformance tests is that you're not allowed to do NAT inside the device, and we don't know how to assign an IP address from a 64 inside the device. The only thing that so we do have issues there, and we need APIs for that. I think, and so we do have work here ahead of us. I think wordsmithing 4291 is something that generated a lot of heat, but I think in reality that the changes are extremely minor, and it was punting. We were punting on those hard problems completely. We just said, well, we want fastest.
So
no,
could
we
you
don't.
please,
I'm about to get to it. So what I'm suggesting is, let's think about what to do with 4291, and I see two options: to like withdraw it, or to say, well, okay, we're gonna. I think if we remove the text saying, by exceptions. If we remove the text saying by exceptions defined in standard stack documents, I think we might get consensus on that and then move forward. I think if we don't, let's just toss it, because fixing the problems is going to require way more than wordsmithing that paragraph in 4291. So I would think we have had over the past few weeks several attempts to keep doing more wordsmithing. And maybe we should just cut that cord and say, look, we're never going to get there by wordsmithing these 5 lines. Either we basically move forward, or we just toss the document. And both would work for me, for what it's worth, because the hard problems are not here.
Well, so the document is parked, and perhaps it shouldn't have been on the agenda today, but just judging from the mailing list discussion, it seemed to be at least worth having this discussion that we have had run through. But it is a parked document, which means it will sit there until we develop, common understanding of where we want to go. And then we have 2 more barriers. There's lots of people that have voiced their opinions on a mailing list that it's not in this room, even if you had consensus in this room. And then there was the IETF consensus that was problematic for this document. So I think there's a few hoops, but it is parked. But now, Tim and Tim, please.
Okay, so this is a working group document. This is IPv6 node requirements. This is just, we've made an update since the last meeting. We expect we're going to put another one out this week based on comments. So if you have any comments, please feel free to put them on the list or come to the mic today. Just a quick reminder, this will be the 3rd iteration of this document. We're working to sync with the router document that's going on in v6 hops. Changes from this time. We added MLD v2. We took out all the text about v1. The older version of this said, hey, v1 was still a thing. Most implementations today do v2. We added 8106 as a must for clients. The mobility text, we took it out. Some people suggested we should just leave it in, so we put it back in. We added Dhcp. Anonymity profiles. Whoa. RFC, we left 1981 alone, and we didn't touch Dhcp PD for host. We left that. There's no text in it. Those are the updates we got from IETF 98. Things we've added, we reorged it a little bit. We added some text about constrained devices, and they should go read some other text and not just implement everything here, is really our recommendation. We added text for Yang and netconf. The original draft had just SNMP. We thought that was a little outdated, so we basically said if you're going to do netconf, do these Yang models. We added some MDNS text. We went 8028, and then we added ECN. So these are our open issues that people might want to get up and talk about. This one, some people have suggested that we put text in particular around the issue of IPv6 extension headers. We can do that, we just need some text. Some people have suggested they'd offer text, we haven't seen anything. So right now there's not anything special about extension headers other than what's in the current updated RFCs. Feel free to jump up during your slide if you have any questions. One of the things we wanted to add text about was the MTU issue for nodes. So we were thinking about adding text in particular for UDP IPv6 and using 1280. Everyone's good with that? All right. This is another draft we're talking about citing. This is going on in V6 Ops. This is prefix per host. This is John's draft, so we're going to add this one in unless people are really opposed to it. All right. This is an interesting one. So for the ready logo testing, we've always required that hosts support redirects. The old version of this draft said hosts should redirect. I was suggesting we update it to what basically every host does support redirects. Obviously, a lot of hosts allow you to turn off the processing of them. That's not what's here. It's just, hey, when you get a redirect, you should understand it and be redirected. I know that there are other people who use this, as part of their architecture. So we can leave it as it should. And then if 4861 goes to become an internet standard, we can talk about this. If people feel strongly. My preference would be to upgrade it to a must, but I think security makes people nervous here. All right. Jumbograms. Brian Carpenter emailed about this and said it's not hurting anyone, we should just leave it in. I don't have strong feelings about this. I'm a little nervous if people think that they're deployed when they show up in a document like this. I'm not aware of a whole lot of usage of this text, but it isn't. Brian's correct, it doesn't hurt anybody, but I don't know of anybody who actually implements it. Go ahead.
Do you want to do comments? Yeah. Okay.
Tim Chan, I think you're running with we sent you some slides this morning that Bob Act. I think you're running on the older.
This is a rev back. Okay.
Because I think we changed it after Brian's comments to say no harm keeping it, leave as is.
Okay.
So Brian's comments won't be in this slide deck either.
Okay. I'll try. If they don't find it, I can go through it. Yeah. No worries. So yeah, do people feel strongly about jumbograms? And feel free to jump up during the. We got some comments about.
I'll just say I think it's fine to leave it in. It doesn't hurt anything.
Okay.
Michael Abrams, yes, I feel strongly about jumbograms, and I would like to keep the text in there.
You'd like to keep it in there, okay?
So it's like typically this just works. So
you're thinking about something else. You're thinking about Ethernet larger than 1500. This is IPv6 jumbograms, which are larger than 64K packets.
Okay.
Yeah, the giant ones. Okay, you call them giant grams or something.
Okay. Yes.
You really don't care about these ones.
No, I fully agree. Okay. So can we? Can we change that word?
I know we need to. It confuses the hell out of people.
Is it a possibility to choose a different word, like huge packet or whatever? I don't know. Is this jumbo? When someone says jumbo something, I think
you think of the regular
1500.
Joel Yegley. I think the observable phenomenon is if they were actually implemented and used, they would be harmful, right? Because serialization is still a thing, and if you are sitting in line behind a very large packet, you have induced latency. There are, of course, link layers where this is appropriate, right? There are link layers where you can create 2 GB frames, right? And those do exist, but they are not, by and large, connected to the internet.
Hi, Tim. This is James Widyat, NIST Labs, and I'm a co-author on Fred Templin's draft that talks about route information options and extending the way those might be used. And I noticed that 6434 and this draft don't really seem to say as much as I think I would like it to say about RFC 4191, the default router preferences, and more specific routes RFC. It says it should support RFC 4191, but it doesn't say anything about what type of host it should be in the context of that RFC. There's type A, B, and C. Our draft that we're presenting this week introduces a proposal for a type D, but it's still early. But I would like to see something in this draft that says this is the type of host that a node should be.
Would you be okay if we said type A? I'm guessing not.
I think I'd prefer type C, but I would like the working group to come to a consensus about what it should say, and then I'd like to see the draft say what it is, so that it's a little bit more clear. Right now, it just says it should support 4191, but
Yeah, I've had this problem in other profile places too. I don't know what the right answer is. I've never gotten consensus from a group of people on what type of host they'd like. I mean, clearly, if you look at the three choices, B looks really nice, but C's work. The problem is you're going to run into here, right, is nodes are different on every network. And the reason that they did write the three types down, we can try. I'd have to go back and reread it and refresh my memory on the exact differences between the B and C, but we can look at that. I hear what you're saying. It's very vague right now. I mean, I think it's one sentence where we say you must implement it, meaning that if someone does it as a type A, that they've implemented it, which is pretty.
And honestly, I would rather that it said type A rather than what it says now, which is it just says it should support the draft.
Okay, well, that's good for me to know that if we end up with type A, at least we've said something.
Eric Klein, in response to, since James brought up 4191, I made a comment that on the mailing list that was, I'm sure, lost in the other bits. It would be. I also would like to have some sort of a must for 4191. We have a herd of vendors who will basically send out a PIO with a /56 and L equals 0, so that you can try to install a route that at least captures traffic toward the router.
Yeah.
That will still keep things working in a multi-link device, where if default root is 0, default router lifetime is 0, and that we need to not do that. That's pretty hacky, right?
Yeah.
Okay. But I mean, they do it because it works, right? So but like we have RIOs in theory for this, and it seems cleaner.
Okay. We'll take a look at that text and try to clean it up.
Thank you.
3G, we stuck some notes in the node requirements about, if you're reading this document, you should go read these 3G things if you're building something on a 3G network. We got some comments. We'll update them. They're listed here. Try not to go into too much detail here about how to do a 3G network. We're really just supposed to point people to the right text.
Okay, Suresh Krishnan, so one of the authors of 7066. And so this is like probably a generic problem, right? Like this, like a 7066 is like a snapshot of the 3GPP network at that point. And probably it needs to get revised. So that was already a revision of something we did before. So maybe it's like time to revisit it in V6 Ops, right? To look at like what's changed since then, and probably like give a better update on things. So like probably sit with Med and talk about it, because at the time there were kind of two different V6 profiles doing the rounds in V6 Ops, as you know. Like one of them, like from the whatever is in the 3GPP specs, and second one is like more like a what do we want in like for all the transition stuff. So kind of we had the disconnect back then. Maybe we can revisit it now and see like, okay, what's the reality now, and then probably do a bit on this.
Okay.
Lorenzo, clearly on this slide specifically, why would we say that 7066 from 6434 BIS? Why are we publishing a new document that has to be which is a host requirements document, which is trumped by another one? Can we not?
Yeah.
Can we not get them to agree or something?
I think what we're trying to say here is, hey, don't read that document if you're doing a 3G one. Don't use this document as your only. Yes.
Okay, Suresh Krishnan, the reason is the 3GPP link model is very specific, right? So there's some stuff that's kind of very useful in other networks that's not useful there,
right.
Because it's like a point-to-point thing. So I think that's what Tim is trying to say, and Tim are trying to say. Yeah. But we can probably word them in a way that it's not a conflict. But there is specific things that are really not required in 3GPP.
So if it's a 3GPP only host.
Yes.
So what about a future link technology? It's well, if you want to go on this link technology, you don't have to implement the V6 host requirements. Well, if you want to go it's like a buffet or a menu. I mean, I guess.
So the alternative, Lorenzo, right, is to No, the alternative is to kind of make this 6434 BIS a bit milder, right? Because if you want to accommodate all the changes for different link layers, then you cannot be as strong as the requirement. So what you're saying is that generically this is what you need to do, and specifically in a link technology, you might do something different. Same thing we do for 6LoW kind of things, right?
6LoW PAN's the same way.
Yeah. So there's two ways, right? Like you said, there's two ways. One of them is we can say most of these things, most of the must should become shoulds in 6434 if you want to accommodate a wide variety of link layers. The other way is to say like, okay, this is the right thing to do, unless somebody specifies an exception and says why, right? So those are the two ways to go forward.
Yeah, and my preference here would be to document the exceptions instead of watering everything down in the document to a should. I'd get real nervous about that because some people would read that quite poorly.
So yeah, Tim Chan. So exactly, and we've kind of got two exceptions in the update here. One is constrained nodes, and the other is this, where we're just pointing at. You probably want to look at this rather than copy it all into here. Particularly when Suresh says that was just a snapshot anyway, and probably will get updated. So a couple of examples of those things are 7828 and 6603, which a general host probably wouldn't do, but it's more useful for people.
Lorenzo, clearly, can't we just say, well, if you support a link layer technology that has broadcasts, then you need to support this. If because like otherwise, it's kind of a worthless document. If it's like generic host requirements, but you can't ever use this on any real link layer, like what do we even have it then? Like why even have 6434?
Yeah, I mean,
and particularly if there are conflicts, it's really bad, right? Now maybe we can go through and ensure that there are no conflicts at this
time. I don't
time.
think there's any conflicts in this case. I'd have to go check. I mean, but yeah, that's something to think about. So we talk a little bit about the DHCP versus RA. We discuss it in 8.4. In this case, what we say is, Slack is required and that you have to get DNS through, a host should support DNS through RAs. Obviously, DHCP is still listed here, and that's going to come up in a minute. Yeah, oh, okay. All right, so then this is where this is going to come up. So currently, obviously, there's an ongoing thread on the discussion of DHCP. The way we have it listed now is we have DHCP stateful as a should. In the case, there are cases where hosts should implement it, knowing that they're going to potentially be on a network that will require that. And the other section we're adding text on is for stateless. But if you want options more than DNS, you obviously have to use DHCP stateless, and that a host should implement that in cases, in some cases they'll need to, but we wrote it down as a should. You should have a good reason not to implement it.
Tim Chan, so just to clarify what the two slides would have said, the first one on the options is it's a must on 8106.
Yep.
And it's a should support stateless DHCP6 if you expect the host to take advantage of those options that aren't available in RA, so like NTP and all those other things. And on stateful DHCP6, the document currently says should implement, and that's currently where we're at.
Okay. Yeah.
Lorenzo, I mean, everyone will just say I hate DHCP6, and it's true. But the thing that I have a problem with in this draft is, like, first of all, we say, well, stateful is optional, but stateless is optional only if you blah blah blah, and then but stateful is a should, which is kind of strange.
Well, so we're fixing that. It's going to be a should for both.
I see. All right.
So we're addressing that issue, and I agree. When I read that sentence, I was kind of like, what?
So in general, like, there's a conflict between what we recommend in various different places, right? So I think specifically, first of all, like, if you, in the same breath, we cite 7844, which says basically don't do DHCP unless you have no other choice. And then you say all hosts should implement DHCP6. Now, that seems just silly, because like 7844, if you read it carefully, says don't do DHCP6 stateful because it's bad for privacy. And so, like, either we don't cite 7844, or we say, we cite it and we say, here's why that RFC that we cited 2 lines above says don't do this, but you have to do this anyway. Or we can say, if you're a host that cares about privacy, then the should doesn't apply to you, but like, we have to resolve this conflict. And additionally, it's my observation, everyone will say that I'm on crack, right? But it's my observation that the only thing that, like, we say, again, like, there's another conflict where we say you should do DHCP6 because there are networks that require it. And we have a BCP that says it is wrong for a network to require it. We do not recommend that. So, like,
I'm just saying we need to make up our minds here. I mean, you know, yeah, we can't just like, it's just not credible to have these conflicting requirements. Hi there, John Brzezowski.
Hey, John.
Man, you gotta loosen up, dude. You know, I love you, man, but seriously. So I think you should say like May, right? I mean, because I still use DHCP6 extensively, and it's not going anywhere, right?
Yeah.
Right. Truth be told, you know, I can kind of sympathize with the like, you know, do I care about privacy? They're my devices, dude. You know, and I'm gonna do whatever I want with them, right?
Yeah. I mean,
Right?
that's
and,
the case.
and he's not yelling at me, so that's a super positive sign, right? So I think the May is probably legitimate. I mean, with the recent news about, you know, like RDNSS for Windows and stuff like that. I mean, and I'll be honest with you. I mean, that's like basic standard plumbing. The one thing that you really should factor in here, though, is like if you ever want to do PD, right? If you ever want to kind of just do PD without an NA, right? That's kind of you don't want to like what's the saying? You know, bite your nose to spite your face, right?
That's what I was actually a little worried about. If we don't say, you know, we have to be careful with what we say about DHCP, because if all of the hosts pull it out and then we later decide PD is a really cool way to give bigger than /64, we're going to have regrets.
Yeah.
And I'm a little nervous.
If you listen to him, we kind of just eradicate it altogether. You know, we're going to regret it in a little while, right?
Yeah, I'm a little worried about
so we got to
that.
temper my, you know, my good friend's attentions here. So I mean, but like honestly, truth be told, I mean, you can live life with, you know, Slack and 81.6, or is that the new 61.6?
Yeah.
Okay, yeah.
Yeah. So, I mean, the thing that we're hearing here, right, is from enterprises that want to know what's on their network and want to give out addresses is where, you know, I'm not sure they're well represented in this room, but that's where we've been hearing this
Yeah, we get that a lot too. You know, one of the things that we want to do there, Tim, you know, this is awful, right? But we basically got to the point where we're like scraping the tables, right?
Yeah, that's what I've heard too.
There could be some work in a different group. I got to talk to Fred about this, but we talked about basically, I mean, you know, when you do SNMP link up or link down, you get like a trap, right?
Yeah.
We should have something analogous to that for, you know, that includes all the layer 3 information about a host. I got to go talk to Fred to see where that fits in. Maybe you guys have an opinion, you know, Uli and Bob, but yeah, the network is now kind of smarter, right? So we want to kind of keep going in that direction. So
all right, so we can talk about the May. I prefer should, but we'll see what the group says.
Hi, I'm Natalie Trenneman. I'm one of the IP6 trainers that Randy talked about earlier. I teach around 1,000 network operators basic IPv6 on a yearly basis. They start from scratch. They sometimes are not even well immersed in IPv4. We're starting to get a problem. Because if I do the training course and I say, there's no ARP, they go like, oh, okay. And then I say, there's no net. They go like, what? And then I say, yeah, there might not be DHCP. And they go home. And and then I haven't even started talk about the 40 extension the extension header problem with the drop rates, the transitioning mechanisms that they're facing. I don't know. I come now at I'm not normally one that stands at the mic, but it's getting now harder and harder to bring the message across that we're doing useful stuff for them. If you see what I mean.
Yeah, I think the DHCP question is going to, you know, depending on the network and the operator is you know, something that we need to talk about. I agree. I think that when you talk to the enterprises and you say there's no such thing as DHCP v6, there's a lot of blank stares.
Yeah.
Back.
Fernando, I'm trying to double check if I understood Lorenzo's comment correctly. So you are saying that there's a BCP document that essentially says that you shouldn't do the DHCP because it's bad. You shouldn't. So what should you use DHCP for?
You know, like we said in this document, there are options that RAs can't give you, right? Like the basic case would be like an NTP, or if you had an option that you couldn't get through an RA, you have to do some version of DHCP.
My observation is that the reason I'm talking about this is that the current text says DHCP6 address assignment. Doesn't say DHCP6 protocol. Doesn't say DHCP6 PD. It says DHCP6 address assignment. So specifically, we have the best practice that I'm talking about says it is recommended that networks where general purpose hosts connect to, so like not a cable modem or an HE device, not a thermostat, but a general purpose host, those networks, it is not recommended that they require that you ask for an address every time you want a new address.
And basically that kind of rules out DHCP-v6 because to get a new address, you have to ask. So that is our current best practice. What I'm saying is that there's a conflict with this text.
So my proposal, that comment aside, is I think that stateless DHCP should be supported, must be supported. I think that if you don't have that in the document, essentially you have a whole working group that is working on something that in practice is not usable. So either require stateless DHCP here or close the DHCP working group.
Wow, that's a lot of.
Barbara Stark, as was said on the list, the BCP that Lorenzo refers to is a specific use case. RFC, whatever, 6434 that's being revved applies to all nodes.
Yeah.
And so just because something that applies to all nodes, that a particular use case says in this specific thing, we actually recommend this, I don't see any contradiction.
Tim Jones. Yeah, I agree completely with what Barbara says. I think the advice about it's the anonymity profiles you're talking about, I assume. I think that's good advice, but having the should in there in terms of implementing it allows you then to have DHCP where the anonymity isn't an issue for you in your deployment. Seems reasonable enough, and I don't think that's necessarily a conflict. I think the anonymity profile advice is very good advice.
I'm just saying if we do want to keep this text, we have to explain why 2 lines above we cite something that says prefer Slack over DHCP-v6. And then we say for all hosts, even those that want to implement this profile, they should always be able to do the thing that we don't recommend. That's all I'm saying. Like, or if we want to put a carve out in there saying like,
So,
should for.
But the thing I want to add here is it says that they should be able to go there. It doesn't say only, right? And your profile is really clear about that it's the only case, which we don't say anything about. So I think we're okay from that perspective, and that we're saying that you should do DHCP. You can have both. You can be running Slack and DHCP and be perfectly happy.
But then we have to say, well, a way of resolving, for example, one way of resolving the conflict with 7844 is to say, do DHCP-v6 address assignment only as a last resort if Slack has failed. That's a way of resolving those 2 conflicts. Because otherwise, you've got 7844, you've got a device.
So here's my thing here with that is that this is what they should implement. It doesn't go into the operational of the network. So I don't think we'd put a sentence like that. But again, I'm with Barbara and Tim in that I don't think that this conflicts directly with the text that's in there. It's not saying that they should do DHCP only. We're saying, hey, you should have the bells to turn on DHCP.
But on base, when would they do that? Because you can't simultaneously follow 7844 and always do DHCP-v6. Like, you just can't, because it says don't do it, and then we say you should do it. So we just, are you saying we should just like leave that up to the implementation?
Well, the people behind you are waving at me, so I'm going to let them go before I answer.
So the should means unless you have a good reason. RFC 7844 provides a really good reason for a specific use case to not do the should.
Yeah.
And that is exactly the way it should work. But we should not take the RFC 7844 and put it back into general node requirements. We have specific cases in our access networks where we are not ever going to be providing Slack. A number of providers do not provide Slack addresses to CE routers, period. And to suggest that 6434 should not consider the CE routers as an endpoint and should somehow be dedicated only to 7844 nodes is ridiculous.
No, but for those you need a must, right?
Yeah.
For those you need a must. Like, those devices must do DHCP-v6 because that's how it works, right? And I'm saying, like, what we have here is we're painting all hosts with the same brush.
So I'm going to suggest that Suresh, with the AD hat on, I presume, is going to have the last word on this particular topic.
No. Actually, so as an author of like 7844 hat on, the draft the RFC specifically states that if you cannot do Slack, so like Lorenzo said, Slack failed. That's not what it actually says in the RFC. So what it says is like if you get a PIO, okay, which doesn't have the A bit set,
yeah,
you do DHCP-v6. So that's not a case you covered, right? I'm sure you thought of it, right? But that's like a valid case, and that would cover Barbara's exception, right? Because 7844 says like do DHCP-v6, like in this case, otherwise do Slack, right? That's what it says, right? So, but That's a specific exception. It's not a failure of Slack. It's just that the prefix didn't have autonomous configuration enabled. So that's like one specific thing I want to say over there. And now with the AD hat on, I'm not closing the DHCP working group because like there's like a lot of other configuration information like Tim and Tim said before that needs to get done. Yeah. And I really don't want to like redefine stuff in arrays again, like every single piece, okay? Even though like at some point in the past, maybe that would have made sense, but not anymore, right? Like, and so, yeah, so that's not an option.
Randy, last word on this topic, please. For now.
Yeah. We want people to eat ice cream. We don't care. Pardon?
Yeah.
I'm a butterfat lover more than a sugar lover. I'm a sucker for pastry. I don't care if they like vanilla, chocolate, or strawberry. My job is to enable them to move from unhealthy desserts with corn syrup in them to good, healthy ice cream. This means that I should make it easy and attractive for them. If they like vanilla, they should be able to get vanilla ice cream.
Yeah.
If they like chocolate, they should be able to get chocolate ice cream. Natalie tried to tell you, she's out there trying to show these people the ice cream, and they're going, what the fuck? And walking away. Okay, and we're hung up in document A says this, and if we tweak that, it will not. We're nuts.
I think that was a good ending on this topic. Thank you, Randy. You have 17 seconds, Tim.
Yeah, I'll be quick. The only last thing is we're going to obviously update all of the changes that happened with the 8200 and the 8201. And then the last thing we have to talk about probably at the next IETF is informational or BCP for this document. I think we're leaning towards BCP, but we'll wait till we finish it.
Thank you. Okay, Fred, so now we're on the section on active internet individual drafts. Those are the ones that have been actively discussed on the list, but they're not working group drafts. Fred, please. And you have 15 minutes and a clicker.
Right. Fred Templin from Boeing. This is to talk about a draft that was presented at the last IETF, and we've resolved some comments that are posted on the list, and we also have a new way of looking at these route information options. So the first draft was posted on the 6-man list in January as draft 00. Comments resulted in the publication of a draft 01, and that we've got more comments on that. And then a draft 01 was presented at IETF 98 in March. And from the IETF 98, we got comments from which we made major revisions to drafts 2 and 3 to incorporate comments. And also now we're saying that instead of just having the route information options in redirect messages, we want to have them in all IPv6 neighbor discovery messages for the reasons I'll get into in the next couple of charts. So this is the common redirection scenario from RFC 4861. We have a source, a router, and a target, where the target might also be another host, or it might be a router that's in front of an arbitrarily complex network. So route information options in RFC 4191 are to be included in router advertisement messages only, and they inform recipients of routes that are reachable by the router that sent the RA message. And so RFC 4191 identifies 3 types of hosts, as James was referring to earlier, types A, B, and C hosts. A and B both ignore RIOs, but type C hosts process RIOs and RA messages. In our new document, though, we're introducing a new type of host called a type D host that has the same type of behavior as type C, but it also processes RIOs and redirect and other IPv6 neighbor discovery messages. So coming back to the redirection scenario again, We have a case where the source sends packets towards the destination via a router. The router forwards the packets to the target, but also sends a redirect message back to the source. And the redirect contains the target address to set to the target address, a target link layer address option with the target link layer, and also now a route information option with the prefix that covers the destination address of the packet. In this case, 2001 DB812::/64. But once we get that redirect message, what we really want to have happen before the source sends packets to the targets is to test the forward path from the source to the target. And the way that it does that is sending in the neighbor solicitation address message to the target and getting a neighbor advertisement message back. So after the redirection, continue to send data via the router until the direct path is tested. And again, to test the path, the source sends an NS with desired route information options directly to the target. Target sends back a neighbor advertisement message to the source with route information options that match the ones it received in the neighbor solicitation. And then the source can populate its routing table based on the NA RIOs and allow future packets to flow directly to the target without involving the router. Use cases, enterprise mobile devices like cell phones and tablets, aeronautical communications, something like an airplane talking to an air traffic controller, unmanned air system networks, even for vehicle-to-vehicle communications, and home networks with multiple subnets, such as we're talked about in HomeNet. And the next step was we want to ask if this can become an IPv6 working group document. Yes, Ole.
Ole Tran. So one question, if you go back a slide or two, here, yes. So why isn't it sufficient, this might be a naive question, but why isn't it sufficient that the target sends the RAO option in the RA?
The target might not be a default router. It might be something like a host that has a 64 subnet connected to it.
But it doesn't need to be a default router to send an RA. I mean, it can send a route to lifetime of 0, so it won't be a default router, but it can still advertise that route with the RAO. And wouldn't that achieve the same effect, I would have thought?
Well, the target and the source don't know anything about each other until the redirect message comes. That's how the source learns about the target, is through the redirect message. Yeah, that's true. RAs are by default multicast. They can be unicast. And we don't want the RAs to go out to all nodes on the link. We only want them to go to the source.
But the target still has to register with the router somehow. So why wouldn't it? Yeah, okay, so if this was a normal, multicast capable link, the target would just send the RA and you would be done with it, right?
But we don't want that RA to go to all nodes on the link. We don't want it only go to the source. And that's why neighbor solicitation and advertisement are unicast.
What's the motivation for that?
So if the source wants to have a more direct path to the destination, it can go through the target instead of going through the router. So you don't have a triangular route. You have a direct route from source to target.
Sure, but what's the motivation for only giving the source that information and not every other host on the link?
It could be a very large link with many, many sources and many, many targets.
Right. But you still have lots of these messages, and that router still has to generate those redirects, which typically I don't like to do as a router because it takes
But that's only for specific source destination pairs, though, where there might be a sparse set of source destination pairs on a link that has many, many sources and many, many targets.
Oh, so you're now saying that the router actually has to go and look up in the table to see if this source should get a redirect or not based on some rule set?
Well, no, the router knows the prefixes that are owned by the target, and it tells the source if the target can be reached directly, if the prefix can be reached directly through a target.
But how would, if you had a million sources on this link, how would the router know which ones to send redirects to? You just said that you shouldn't send it to everyone.
No, it's the redirection is the same as happens on any ordinary IPv6 link. So the source sends a packet to the router knows that there's a better first hop through the target, and the router sends back the redirect to the source.
Right, so the only difference, the filtering you have here is that the source actually would have to actively send a packet to something behind the target, which would generate the redirect, while if you send the RA, then you would send it regardless of that
sending packets
Yeah.
or not.
Yeah. Okay. Yeah.
Eric Ving, I think it's a sensible problem to solve. I'm just a little bit annoyed, put in the same vein as Ule, that the source is sending a neighbor solicitation for an address which is in a different link, so not its neighbor.
No, it sends a neighbor solicitation message to the target's link local address. It doesn't send it to the destination address.
Okay, because I was hoping that if you want to probe something which is beyond the target, you will do something like routing and assurance.
Yeah, we're not doing that though. What's happening is that the source is asking the target to please send me back your router information options. It's not going all the way to the destination. It's only going to the target and saying, neighbor solicitation in your neighbor advertisement, please include router information options when you send me the neighbor advertisement.
Okay.
Jen Lenkova, I looked through the draft. Sorry if I missed it, but I'm not sure. How does target tell the source that it doesn't have the prefix anymore?
It can send back a prefix with lifetime 0.
Only if it does know that it used to have that prefix and it doesn't have anymore. What happens if target got rebooted or replaced or something else? If it doesn't have information of the previous state.
It can actually send back a neighbor advertisement message with no router information options if it no longer has that route.
So, okay, the source used to send traffic for this prefix to target. Suddenly it sent another packet and target doesn't have that prefix anymore. So
what happens then is that this target sends back a destination unreachable.
But the destination unreachable might mean that only this particular address is not reachable, but the prefix is still there. How do we distinguish between situation one particular address and /64 is not there and the whole prefix is not there?
Well, there's a difference between destination unreachable, host unreachable, and a network unreachable. So it could send a network unreachable.
Okay, so by receiving the network unreachable, source removing the route, okay.
Yeah.
Michael Abramson, so what happens if I do an RIO of a /112 that is within the /64 that is on the link?
That depends very much on that discussion about whether we can have longer prefixes than 64.
This is not like addressing, this is prefix and routing.
Right. So the target should send back its largest claimable prefix. And if that largest claimable prefix is a /112, then it sends back a /112. And that's what gets put into the source's routing table then.
Okay. So you don't see any need for having, I don't know, sanity check is we shouldn't have any rules about what you should and should not accept, like for if it's within something that you already have on link on the interface or something like that.
So the way we're seeing this link sanity checking working is that the router will send back a route information option that it knows the target has at least that much of a prefix. And then when the source sends the neighbor solicitation to the target will come back with a route information option that gets sanity checked against what the redirect told it. So the router is authoritative for the link. And the source and target get to know each other through the router.
Okay. So the router is authoritative for the link. Okay.
Yeah.
Can I just ask a sort of a clarifying question? So the thing you're calling the target, it's really a router, forwards packets to somewhere else.
Yeah.
So I think it gets confused so it's better to think about it as a router, but I think it's making this very confusing.
Well, for redirection, the target can be either a host or a router, and this is the case where we're talking about it being a router.
The definition of a router is something that forwards packets to someone beyond itself. So it's
That's
a router.
right.
It's not something else.
That's right.
Interruption, please. It might not necessarily be a router in 6-man terms. It might really just be a neighbor discovery proxy.
And
Not according to the picture.
the other thing about the target.
Actually, no, I think it actually does have to be a router. Yeah, it does have to be a router. Yeah, it would have to be a router. I'm sorry. It would have to be a router. It would have to be a router. But that would mean in terms of neighbor discovery, its R bit would be on.
Yeah. But, in terms of what type of router it could be like your cell phone that has a Bluetooth network behind it or some kind of, LAN behind it. It still acts like a host that doesn't know that forwards packet's not explicitly addressed to itself.
There also may not be any dynamic routing protocol on the link that has the source, the target, and the router. There might not even be that.
Well, the router would still need to know about the target and what prefixes it serves. So there has to be some sort of protocol between the two for this to work.
That's right.
Yes, but it might not be a dynamic routing protocol.
Lorenzo, clearly, how does when router gets renumbered, how does it like clear the state?
So if the router gets renumbered, it has to propagate that renumbering down to the target.
Yeah.
And the target would be through prefix delegation. You'd have a reconfigure would be sent, for example.
So then there has to be a dynamic protocol between router and target.
If you're going to allow for the case of the network being renumbered, yes.
Well, but if you don't, then it's a regression, right? We have this works today using 4861, right, with RAs and RAOs. And if you don't allow that or you don't build it, then basically we've got this black hole. We're basically building black holing capability, because if the link gets renumbered, the source doesn't update its whatever database it's using to track which prefixes it's routing to target.
What would happen is if the network got renumbered and the source still had stale routes, when the source sends the next packet, it will get back a destination unreachable, network unreachable.
That assumes that target has gotten that renumbering information.
Right. Right.
What, like, okay, so I guess the question is really like the same as Ule's, like, why, like, you're basically saying this is scoped to links only where RAs are too expensive? Because I don't see if target could send an RA, why that would be worse. It seems like strictly better in all ways. So maybe we should just scope, if you want to take this forward, you can just scope this to a case where there's some reason why target can't send RAs.
Well, again, the RAs being multicast, we don't want to disturb all nodes on the link.
That's fine, but on certain links that makes sense, on certain other links it doesn't. So if you scope this to a situation where you can only, with this whatever standard this becomes is only used on links where RAs are not practical, because router has got to be telling source this stuff, right? So like router has to be sending RAs presumably. So yes. we have to, this only makes sense when router can send RAs to all the sources, but the targets can't send the RAs because of some asymmetry in the number of hosts involved and of like specific characteristics of the link type. So maybe if we have an appropriate applicability statement where it says that says where this makes sense.
Sure.
Jelinkova, stupid question. Can target send not NA back to source, but array back to source as unicast?
Can it send, I'm sorry, say that again?
Can it send array back to source? When your slide says target send NA back to source with RAO, can this packet be unicast array?
Well, so the general case for sending a router advertisement in response to a router solicitation is to send multicast. Unicast is permitted. But with neighbor solicitation and neighbor advertisement, unicast is by default.
Yeah, but you're already doing something new, right, in this case. Can you just change your algorithm so that instead of sending NA back, you're just sending unicast array back with RAO and then problem solved, right? It's just a normal array. We know how to deal with renumbering and so on.
The problem with the RA, though.
So we are out of time. I think we're going to need to continue this on the list.
Okay, I'll stop there then. Thank you.
Thank you.
Yeah, thanks, Fred. So Fernando, you are next. Also an active individual draft with 50 minutes, please.
I'll go quick. I'm Fernando. I will be presenting the address usage recommendations. ID, the last revision that we did. Is the same document that Christian presented at the last IETF meeting. As a quick overview of the problem that we have here, essentially, virtually all nodes have multiple addresses of different properties, like stability properties, different scopes, etc. When it comes to outgoing address selection, it's already well specified in RFC 6724. However, when it comes to, let's say, addresses that you'd use for receiving incoming communications, those are not actually well specified. And the dominant practice is essentially to bind a service port to essentially all the available addresses. Or actually, what you do is you bind the socket to the wildcard address. There are some problems with this. One example, this was a well-known example of some Raspbian systems in which they were communicating with an outside system, and an NTP server was at the time, and right after that, they would receive a port scan. So the fact of doing something, let's say, like client-side communications, essentially exposed them to, in this particular case, network reconnaissance. There are other things that might happen when you just, bind the wildcard address, that you might have an application that you are expecting to be employed or used only, for example, on some limited network, like local network. But if you're binding all addresses, obviously that application could be, let's say, used from anywhere, as long as the scope of the addresses allow. So what are possible alternatives to that? Well, in theory, applications, they could, just enumerate all the possible addresses, pick the addresses that are, suitable for the specific application. A problem with the, current API is that you can bind specific address, like one address or all of them, but not the subset. That's as much as you can do. You could possibly, for example, employ different sockets. So for each socket, you just bind one address, but that's problematic for different reasons. First of all, it tends to be like very platform dependent and non-portable to actually learn the actual addresses that you have on the system. On the other hand, you don't really want applications to have to deal with this, obviously. And besides that, even if you got applications to do that, even if they were able to learn the addresses, then they would also have to be able to check the properties of the addresses and include all that knowledge on the applications, which is really not nice. There are other things related to address usage and configuration, which is nowadays the address selection is performed by the application, but configuration is done by the system. So you might have, for example, applications that they might want to have just a specific IP address for that application instead of having to employ the ones that have been configured by the system. But again, right now that's not possible, okay? Because it's the system that decides which addresses are configured, of which types, when they are configured or changed, etc. So the idea with this ID, essentially, we were meaning to, try to provide a problem statement and also, discuss the possible solutions. One of them might be to, let's say, extend the API or something like that. Based on the feedback that we received at the last IETF meeting, and that's actually like a question that we have for the working group, we are probably thinking about focusing the document on the problem statement because, working on the solutions, might be like too much for this single document. Changes that we apply for the document, essentially some reorganization and some minor editorial changes. And among the things that we did, we applied, or we tried to address feedback that we got from Dave Taylor, as far as I remember. Noting, for example, that when it comes to how you select which addresses are employed for an application, well, I personally believe that let's say the most let's say correct or clean way to do it would obviously be to be able to specify that at the application with some sort of API. But at the end of the day, there are multiple ways in which you can do that. For example, if you were able to specify a subset of the addresses at the API level, then it would be the TCP IP stack itself that would be doing the filtering. So depending on which address the incoming communication or incoming packet arrives, it would be the stack itself discarding the packets or accepting the packets. Another option is for the application to do that filtering. Obviously, that's suboptimal for a number of reasons, among other things, because, for example, if you were trying to do this at the, let's say, for TCP applications, that would mean that the application itself would already have to, accept the connection, and only after that, the application would be able, for example, to tear down that connection. And besides, obviously, that means that every application will have to re-implement all this stuff, which is really not nice. And obviously, you could also, for example, or somehow decide which addresses are allowed for incoming communications by filtering packets. So, for example, you could, let's say, whitelist some specific addresses, like stable addresses, on which you might want to receive incoming communications, but not on the other ones. So these are essentially the changes that we applied on the last revision of the document. Based on the comments that we received at the last IETF meeting, we kind of have the idea that it might be better to have the document focus on the problem statement as opposed to let's say, for example, trying to extend the API or providing recommendations in so many areas here, because there's which addresses you configure in which scenarios, how you employ them, which scopes you might prefer in one case or another, which should probably be too much for a single document. So let's say there are two questions on our side. The first one is whether you should leave the solution space for a different document, and the other one is whether the working group is interested in working on this stuff.
Any comments? I suppose I have one while Eric is walking up to the mic. Is this problem all implementation specific in the sense that it only applies to applications using BSD sockets, and other implementations of different APIs of the network have solved this, or does anyone know? Do you know?
Not that I'm aware of. Obviously, the ones that are used the sockets API are affected by this, but right. I couldn't speak for all applications.
Eric Klein. Would it be in scope for this document or the solution space to address applications requesting special use addresses for their use only?
Yes, actually, that's one of the things that we discussed in the document, and we're saying, well, we could have scenarios in which the app wants to use an IP address for itself, but currently you have no portable way of doing that.
Right.
So that's part of the problem.
That might actually address some other things that were discussed earlier today. This is an API I think we should have. Applications that say, I want an address, and by the way, it should only be mine. Because there's other issues here as well, and that is, even if you were to do something like reuse the IPv6 prefer source header, home or temp or whatever it is for listening sockets, you'd still have to have some way to notify apps of addresses coming and going, because that app might want to take that address and put it into some namespace. So getting updates about that stuff is in fact a real problem. I don't know if it's permitted to be a solution, but this is stuff that I do think should be worked on. Thanks.
Eric Vink. More on the solution space. You may be interested by reading Pierre Fitzer and a few other people draft on provisioning domain that tends to give you partial answer on this. And there's also another European funded project called NEAT that was part of the hackathon yesterday, which also tried to get a post-socket API for this kind of stuff.
So that's an API for what specifically?
In the case of NEAT, it basically, the application can say requirement and characteristics of the application. Then there's kind of a complex system based on policies and blah, blah, that selects the right source and the right destinations, addresses. Could be multiple, right, with multiple Dhcp.
But that's just also for incoming communication? Or?
Yeah. Okay. Server and client.
Okay, that's cool.
Tommy Polyapple. So kind of going on in that, NEAT's also involved with more broadly kind of like the TAPS working group, which is kind of trying to work on like a post-sockets API. So for people who are doing client APIs like us, I think what would be useful out of here is to, not necessarily just have like the solution, but what are the requirements that need to be exposed to give people the right knobs on this? What are the filters that could be applied on the higher level service description, such that when we are doing potentially a high level connection that's ending up going on multiple interfaces or doing multipath, that we have the right knobs for filtering that are appropriate to describe this. And having it in terms of not just the socket API would be great, because we are not always using that.
Yeah, I think that for the solution space, it's not just the mechanism that you might have available, like an API, but it's also providing some advice on, let's say, regarding which kind of address you might want to use. For example, if you have a roaming device, you might just want to use temporary addresses that are not stable.
Exactly.
But right now you have like a toolbox, like a bunch of things, but no guidance regarding what you might be using.
Hello, Philip Teasel to you, Berlin. I also wanted to point out to stuff from the TAPS working group that is more or less going to that direction. So this is my own draft on socket intents, which is targeted rather to the client side, but also could be extended in this direction. So say just by saying what kind of use you're intending for opening this socket on a more generic level, and then take from the operating system the choice what really addresses to bind to.
Yeah, I think that in that case, besides the that thing of having an API that you might like specify the intent, and it might come up with the addresses that are prepared for that. There's also supposed to be like a document, whether this one or some other one, that says, well, for this kind of intent, these are the properties that you might want in an address, besides the API itself.
True.
So from what I'm hearing, I mean, I'm a little unsure here of, the demarcation point here between, the internet area, transport and application. And, if this is a, problem statement to transport or above, or I certainly don't think we can do all this on our own purely in 6-man. So I think I need to go back and, talk to our AD and transport people to see where this work is best done. I see Suresh is at least nodding. Yeah. Dave, do you want to?
Dave Taylor. I'll just make my standard comment that I make about every IETF at least twice, which is the APIs and specific languages like C sockets and JavaScript are owned by other SDOs. And for the sockets API, we don't have an official liaison relationship with that organization, but we do have an informal liaison person, and that's me. And so if this working group or anybody else wants to draw attention of that body to any particular draft or work out of the IETF that might be in the abstract API sense, let me know, because I'm the person that is tasked with doing that. So.
Okay. Super. Thank you, Dave.
As a side comment, I think that, I understand your point. I think that, when it comes to addresses that from an applications point of view, they might be desirable to use or not. But I think that there's another part from my point of view that, belongs in 6-man, is the fact that at this point in time, we have like addresses of different scopes and properties. So that's like a toolbox. But we are not providing any guidance on, well, when you should use which one. Like, you might want to do only temporary addresses, or just only stable, or you might want to do both. And in which cases you might want to use one or another, or addresses of different scopes. I personally believe that that specific part belongs in 6-man.
Michael Abramson. So I think this is extremely useful that we get like a problem statement, and the more people that can think about in this area what the needs are and what's not being done today and so on. I don't have an opinion on where this should be working, but I think it's great that we get like this is done in TAPS. There's been in int area, but PVDs, and there's work going on that is related to this all over the place. So if we could inventory that at least on the list as well, that would be good. So and I do support. I think the socket API is very old. I think for a lot of programmers, it's really hard to use it. The more we can help the application programmers, the better the end users are going to be able to efficiently use the network. So I think we need to do, I'm not sure that we need to do work. So the whole APIs, if that's done here or not, that's contentious, but I think it needs to be done, and we need a replacement for the socket API that is open source and so on, and it's not vendor proprietary.
So, Dave Taylor, that's a fine discussion, but this is the wrong SDO for that. There are other SDOs that is the appropriate discussion in, and that's what I was talking about. This organization, in my opinion, should do abstract APIs, which is ones without the language-specific binding. Meaning it's not the C API or the JavaScript API. Here's the set of input and output parameters that any particular binding should have. Here's the programming model that we want applications to use, right? That stuff is actually really good for the IETF to do because other organizations are not experts in that part. Right? They look to IETF to say, well, what's the right way to do it? And yeah, we'll specify the way to do it in JavaScript, or we'll specify the way to do it in C++11 or whatever it is, right? And so they're the ones that have expertise in the language-specific binding. So for example, when the IETF did the RFCs that is like the sockets APIs and the multicast sockets APIs, right? We sent them over to the Austin group, which is the group that owned the C APIs, which is IEEE and Open Group and it's ISO, IEC. Yeah, right. And so that triple is called the Austin group, right? They publish a common specs. And so they said, you're doing it wrong, okay? They said, for example, set sockopt is a really bad API. ioctl is a really bad API. We don't add any new socket options. We don't add any new ioctls, right? Because IETF people often think, well, I'm just going to add these socket options and ioctls. Those are the bodies that says that's not how we do it in that language anymore. That's a deprecated concept, right? The concept is you define a new function, for example, is what they told us. And so we revved the API in the RFC, this is before we made it to become an RFC, to say, well, there's actually new functions. In an appendix, we said, oh, and if you happen to implement those functions via a sockopt because you'd already started implementing it, then here's some socket options in the appendix. So it's that style of discussions that happens when we go to external review. And that's the type of stuff that we got to do when talking about a specific language. So I agree with that, with what you said, but that's actually a topic of a different SDO. That when you talk about the model, which is the other part of your comment, then it's absolutely in scope, and that's what I think we should be doing.
So I was thinking more like the requirements for the
Mike,
API
Mike, please.
and like behavior of the API, not the actual API.
And that's the style of stuff that MIF was looking at, and I said that's actually a good direction to go in, and I support that.
So Dave, if I understand you correctly, you would agree that writing a problem statement, stating that we have all these different types of addresses and there are different use cases, and that's something that has to be reflected to applications to make that choice. That's something we could do here, but the actual solutions, they would have to be done in other SDOs.
So there's three ways you can break the problem into three parts, and at least two of them are good in the IETF. The first one, as you mentioned, is the problem statement requirements. The second one is an actual abstract API. Right. Here's the programming model. We think you should actually open a socket or something that's like a socket and do operations like read and write on it, and you should bind and you should listen. That's an abstract API, right? Saying here's how to express that in C or C++ or JavaScript is the concrete one. It's only the third thing that's out of scope. If you say we have a model which is we'd like to enumerate addresses on an interface, we'd like to get properties of those addresses, and here's the set of properties you want to expose. That's what we should be doing in the abstract API sense, absolutely. And so it's not just the first part. I think the second part is also important too.
Okay, good. Thank you.
Okay, I think that's a plan for going forward. And what Dave suggested.
Sorry?
I think that's a good plan for going forward with this. And then later we can have the adoption call. But I think there is little support, but I think we need to sort of probably see it structured in that way first.
Okay,
perfect. Yeah, thanks. Thanks a lot, Fernando. Thank you. Okay, Jen. Oh, colors. Color.
So, I'll be quick. So yeah, we all know that if you're using Slack, you configure IP address on a host, and then there are few conditions when host might stop using this address. Obviously, when preferred lifetime expire, but because the preferred lifetime default value is 7 days, it basically never happens. You can explicitly invalidate it by sending PIO.
The last one is not true for Linux kernel default behavior.
Even worse, and you'll see why. So yeah, sometimes, yes. So basically, sometimes I want host to stop using that address, right? So, for example, because host moved to another, what I called L2 domain, let's say VLAN, for example. Or if we renumber a router, so basically this layer 2 domain now has completely different addressing. And unfortunately, ideally, I would expect that if host moved to another layer 2 domain, it should reset the interface, and it's not happening, as you just said. Not always, at least. And if renumbering is happening, routers are expected to explicitly invalidate the prefix information by sending PIO, right? Unfortunately, sometimes even if host should reset the interface state, it's not happening. Sometimes interface stays up. And when a router says arrays, they sometimes not received, or sometimes routers do not send them. It's all leads to very bad user experience, support tickets, me being unhappy, and so on. That's why I'm here. For example, I have 4 scenarios here, and I've seen 3 of them, and I've been told about 4th one. So, automation is a new black. We all love reconfiguring routers automatically based on some expected state of the network. The problem is Slack is a special case when it's not enough just to push new configuration. You need to explicitly invalidate the previous one. So let's say my network intent state changed, and now this particular interface has different net block assigned. My system pushed the new configuration, but hosts do not know that they should stop using the previous one, right? So we already have a broken connectivity. And while our vendors do allow us to use this beautiful feature of rolling back the configuration to the previous state, in this case, it doesn't help. So even if my support guys roll back the configuration, again, now we still have the broken state of the network because some hosts still using the old addresses, some hosts are using new ones, and so on. So in this case, automation sometimes make life harder. Second scenario, we are doing proper renumbering, let's say, right? We actually push in the correct intermediate configuration to invalidate the previous state. However, arrays are unfortunately multicast, and unfortunately multicast is not very reliable on Wi-Fi, so sometimes host might not receive an array and still trying to use the old address. Again, broken connectivity. Again, automation on layer 2. If again, for some reason, my network is configured automatically, I might push some configuration which change the VLAN. Great, I'm changing the VLAN. Hosts have no idea that address has changed. Broken connectivity. Again, rollback doesn't help much, sometimes making everything worse. And there are also bugs in .1x supplicants which do not reset the addressing state after successful reauthentication and VLAN change and so on. Third scenario, we have router which got, for example, Dhcp PD prefix, and then my router got broken, I replaced it with another router, and all hosts behind that router did not detect the change because they have no way to find out that it's a new router anymore, right? And this one, there is a best operational current practice document in RIPE about Dhcp PD, and it explicitly recommends using static Dhcp PD assignment, mostly because of this. Because if you're using dynamic assignment and assign prefix randomly every time, you might see this and have very unhappy clients. So theoretically, Rule 5.5 might help in some scenarios because, okay, new router, new layer 2, new link local address. With Rule 5.5, host will probably pick up the new prefix. However, first of all, not all operating systems implementing Rule 5.5. And secondly, it would not help if link local address of a router did the change. For example, in case of renumbering, or some people love explicitly configure VRP link local address. So even if you move to another network, you might still see the same link local. So, proposed solution. Let's just introduce another second to last rule in the default address selection. Because if host received one PIO long time ago, and it just received another PIO with another prefix, I suspect that in many cases, the most recent PIO might be slightly better to use because it's kind of more fresh. So the old text, we have very last rule, use the longest prefix match. I actually do not know how often this rule is actually used. So let's add another one just on top of it. If we have no other way to select if you have no other tiebreaker, right? Let's just use the most recent PIO we have. So if host has one PIO received a long time ago and we got a new one, let's use new one because most likely it would be better. And so the question is it a good idea, or shall we just do something else, or is it a problem?
Lorenzo Colletti, I think our Linux workstation's already doing this, right?
Great, let's write it down.
They already, like, well, but if it's already doing this and it's not helping, then maybe it's not very, yeah, I don't oppose this. I think the Linux stack does this already. Specifically, it adds the address, it adds new addresses at the end, and I think it always uses the last one. But it doesn't always do the right thing, because depending on the order in which they arrive, things might be correct or incorrect. Specifically, it's particularly bad if you misconfigure it and you send it something new that's broken, and then you immediately roll back and it was working perfectly fine, and then it breaks. So, I mean, this feels like a crutch.
Okay, so if you misconfigure something and you roll back, for this, at least some vendors have been asked to explicitly send an array every time array-related configuration on the router change, because it's not the case currently, but actually, I believe it should.
Can you go back up one?
So we have 3 minutes.
What it does is when the address was created, so no, it doesn't do what you want. So yeah, maybe it's going to work.
Suresh Krishnan. So I was just thinking of the case where there's like multiple routers on the link, let's say 2. And they're like kind of like staggered in sending the arrays. Like this rule 8 looks like it's going to flap.
No, because if you have multiple routers, okay, so it's the very last rule, right? There are other rules on top of this, right? So in case if you could not use anything else, because if you have other rules like rule 5 or something else, yeah, let's use this. This one is just instead of using longest prefix match.
Okay.
And it's for what address to use for initiating new communication. If you have multiple routers on link and it's going to flap for some reason, probably it's good from load balancing perspective even.
Okay, sounds good. Thanks.
So it's still not unpredictable, right? If you have multiple routers on link.
Okay, that's okay. Thanks.
Tim Winters, UNH-IOL. So Rule 8 is my only advice here. Was I'm a little nervous about implementations keeping track of when they get PIOs for a variety of reasons. Haven't tested this. My preference would be to just stick to the preferred lifetime. In Rule 8, that's pretty complicated to tell them to process the PIO in the order of what they get it. My advice would be to just do it based on the lifetimes. So you said if they can't process it to do this, they should do it preferred on the lifetimes. I think the rule should just be about the lifetime left in the PIO or PIOR.
Okay. I was trying to address the situation when preferred lifetime are different between new and old, and yeah. Okay, if you think it's, we could do probably just preferred lifetime.
Yeah, Dave Taylor. Let's see, a couple different comments. I understand what you're trying to do. I think somebody else mentioned there's an issue if you have 2 different routers with different prefixes and they happen to be configured with 2 different preferred lifetimes and they're refreshing, here and there, or whatever. But you're just saying, well, you're just going to beat a longest matching prefix and keep everything else the same. And so maybe that's not so bad. That's my first comment. Second comment is that I think this behavior is already allowed in the existing RFC. It's just not explicit because it already says Rule 8 may be superseded if you have other means of choosing among source addresses. You're just proposing other means. Okay. And so if somebody were to be doing this right now, they would be perfectly compliant with 6724.
No,
that's my second comment. Oh, go ahead.
Yeah, I would just like to probably have it documented, so for example, implementers could read it and use it if they didn't even think about it. So,
right. My third comment is when going to 6724 from 3484, one of the goals was to keep the rule numbers the same. And so if people are familiar with 3484 and they say Rule 6 and somebody looks at 6724, Rule 6 is still Rule 6. And so that's why we ended up with things like Rule 5.5. And so I would suggest changing this slide in the document to say Rule 7.5 and Rule 8.
Or Rule 8 and 8.5? What would you prefer? Because they kind of together
use longest matching prefix is already Rule 8.
Okay, yes.
And so you're renumbering that to be Rule 9. Avoid renumbering.
Okay, so Rule 8, Rule 8.5.
Because you're adding one in between existing Rule 7 and existing Rule 8. Call it 7.5. That's how we got 5.5. Yeah.
Good to me.
So we are out of time, so real quick.
Marcus Keane, as an operator, I'm curious about, so number 1 and 3 are really automation problems. So is the intent to sort of to mask the automation problems, or is it just to have recoverability?
I think it to make people life easier and make the protocol more robust to human automation error, because people already believe IPv6 is too hard, let's go shopping. So why not do some minor tweaks which might make life easier, and in case of failures, allow us to fall back, to recover faster.
Do you have an implementation of this, Jen? Or if not, I would certainly encourage people to implement it. And
Lorenzo
prove
just
that
said some Linux already doing this, so kind of.
Right. Yep. It would certainly be interesting to see, because I'm sure we'll find another thing that breaks. But thanks, Jen. Pierre.
So, hello everybody. I'm going to talk about the inter-area provisioning domain draft, the first iteration. Those are the authors. I'm Pierre Pfister. And it's quite good fit, actually, after the two previous presentations, which have been talking about address selection. These are examples where you can actually have more addresses to pick from when you have multiple interfaces, one from your phone, one from your Wi-Fi, one from your wire. And actually, even when you're connected to some interfaces on some link, well, in the end, you can be connected to different services like multiple ISPs or a service like a VPN. So the way we used to do that is like, well, hosts would typically pick one of the interfaces that they have and ignore the others, like use the wired because we assume that wire is better than Wi-Fi. Like, this is obviously not the best way to operate. And on the network side, when we wanted to provide multiple services, well, we would classify the traffic on one side and NAT at the exit of the network. This is not exactly how we want to operate it. I think there is a good progress overall in the IPv6 specifications to go to going through a path where we can have a way better design. So the first thing to do is obviously to assign multiple addresses to hosts. That we know how to do already. The host can support multiple addresses, and we are talking about source address selection. We have been designing a solution like that where you would get addresses from different ISPs, from different services in HomeNet, that's specified. And there is work being done, and I would like to apologize because that draft ID is absolutely not the right one. It has been adopted since then, and it's like the third iteration from Jen's work, and that's for corporate network. The second step is to teach the hosts to be able to be more clever about how they pick source addresses. So one solution is obviously like MPTCP, to just use all the addresses or many of them and just use those that work. Other solutions are relying on the fact that hosts will be able to make more clever decision. And you see, based on the previous presentations, that there is work to improve the way the hosts behave in terms of source address selection. But the problem right now, and we are here, the final point, is that the hosts have to deal with very few information when they have to select a source address. They can use the router, they have the PIOs, the more specific routes, the router preference, these kind of things, and we have an algorithm for that, but they don't exactly know what they are connected to. And so that's the purpose of this draft. The first point we want to do in this draft is to be able to identify what we call the provisioning domains, the PVDs. That notion has been defined by the MIF working group. It's provisioning domains. PVDs are a consistent set of network properties that can be implicit or advertised explicitly. That's the definition from MIF. And so we want to differentiate the provisioning domains with names. Those names are fully qualified domain names, and I'm going to that later, the reason why. So we want to identify those. The second thing we want to do, and that's the key point, is that once you are able to identify the PVDs, you want to get more information about the nature, the characteristics of each PVD. because the host will, I mean, the application may have some certain needs that can only be fulfilled by some properties in the links, and you want to be able to know those properties. So first, here is an array option that we are proposing. You can have at most one of those per array. The name, the PVD ID is a fully qualified domain name, as I mentioned. You put this option in the array when you want an implicit PVD. If you don't put it there, well, you have automatically an implicit PVD for those hosts that support PVDs. The legacy bit is used to be able to attach the IPv4 configuration to a given PVD, because we don't want to modify IPv4, but you can still know that the IPv4 is for a PVD. The H bit is a part of the interesting part. It's a bit that tells you that you can get more information about the PVD doing an HTTPS request, and that's next slide. You also have a sequence number, because everything in arrays is push-based, so you want to be able to push some new data, some new PVD properties, so you just increment the sequence number to do that, and you have a lifetime as well. The second step is, once you get the PVD ID from the array, based on that, if the H bit is set, so if you know there is some more PVD additional data available, you construct an HTTPS request using the PVD ID, so the fully qualified domain name, and you use this path here. So in the draft, it's pvd.json. We got some feedback. Now, next revision, it's going to be .wellknown/pvd proposed. The point being that the information that you get from that, the additional information, is attached with the network information that you got from the array and from Dhcp, if there is Dhcp. This is an example of what you can get in this additional data. So most importantly, I mean, the first useful part is you get a name. So the user is actually able to see what it's connected to, a localized name as well for different languages. You have an expiration date. You put the prefixes that you're going to use for numbering this PVD. So you can, the host can validate its own address based on this prefix. And you put the characteristics of the link. Those are just informational. They are not strict, like we want to define those, but the idea is not to have a precise meaning, but some more hints for the host. Some other examples that you can use is the fact that there is no internet connectivity, or is it metered or not. And one thing that we did during the hackathon is the captive portal URL. So you could, based on the PVD additional data, you would know that there is a captive portal, and you would be able to connect to the captive portal to get access to the PVD. Finally, once you get all this information, in this example, like if you have a host that is receiving two arrays with two different PVD IDs, kind of classify the different configuration information that you get. You have the information that you got from attached with one PVD, and the one that you got from a different PVD. The point of this draft is not to completely modify the way the hosts do source address selection or default route address selection. It's not about a new algorithm or all that. We don't want to modify it. We just want to get some more information and allow the applications based on an application basis to behave according to on a specific set of PVDs. Like on this example, you would get some application using one PVD, some other application using another one, and maybe some application using multiple of them. So we have quite a lot of implementation stuff about that. I'm not sure I have time to dig through all that. We have Linux in the hackathon. We have
2 minutes.
2 minutes. Okay. OpenWRT, iOS, some kind of experimental work from Tommy, and there was integration in the NEAT project. There will be other presentation in the Inter-IA and Captive Portal working group, and I'm very interested in getting 6-man feedback on particularly this array option. And overall, if you think it's a good idea to get that additional information.
Okay, thank you. Any comments?
Jan Linkova, one question and one comment. Question, I can remember, do you explain how to deal with conflicts if what you're getting in other array options conflicts what you get in your JSON or whatever file is?
So in terms of PVD ID, if you get multiple times the same PVD ID, means that the different arrays are complementary. They belong to the same PVD ID.
I'm talking about, like you said, you have some prefixes, for example, in JSON. If you receive other prefixes in array or in array, in addition to this, how are you dealing with?
So the point of the prefix here is to be able to validate its source address. So if you get a PIO based on this PIO attached with a PVD ID, you do the request, and from that request you get this JSON, and in the JSON you find a prefix, then you just verify that your source address is within that prefix. You don't really have to validate, cross-validate the JSON objects, I think.
So Dave Taylor, I believe that I understand this, and I think this works and has advantages for regular hosts. I think the only disadvantage that I can think of is for a constrained host, because you're actually using multiple mechanisms, using RA and DNS and HTTP and SSL, and if you don't implement all of those, you can't get the information. And so it may not scale well down to a constrained node compared to things.
Fred, please come up.
I absolutely agree, and that's why the fetching of the additional information is optional.
But I'm saying constrained nodes may need the information, and if you had a way of, say, putting it in the array or putting it in some protocol they already did, then it would scale down better and be more useful. But other than that, I think it's fine for the regular host.
Thanks a lot, Pierre, and let's continue this one on the list. Thank you, Fred. You have the last session of today. Thank you.
Okay, so I want to talk about something that we're calling the arrow address. This is a draft that was first posted back in June as a draft 00. Some list discussions showed interest in the concept. And there were also questions about the FE80::/10 or FE80::/64. And there you've got a pointer to the document. So the arrow address happens when a node N receives a unique IPv6 prefix delegation, for example, 2001 DB812/64, through whatever means, whether it would be DHCP-v6 prefix delegation, manual configuration, or through whatever means. The node N then embeds that prefix in the suffix of the IPv6 link local prefix. So in this example, we have FE80::2001 DB812. So the delegated prefix appears in the interface identifier of the link local prefix, and we call this the arrow address. So what are the advantages of using an arrow address? First of all, you get stateless IPv6 link local address auto configuration. You avoid the need for DAD because the IPv6 prefix delegation is unique, so the arrow address must also be unique. It can be used as the source and destination address of IPv6 neighbor discovery messages. And it also links IPv6 neighbor discovery, in particular the IPv6 neighbor cache, with IPv6 forwarding, because you have prefix information in the neighbor cache, and you've also got prefix information in the forwarding table. Prefix length issues came up on the mailing list. The IPv6 link local prefix, according to the specs, is FE80::/10. But RFC 4291 link local address configuration assumes :/64. Therefore, the embedded prefix length is restricted to /64. But what if we could use a shorter FE800 prefix? For example, if we had FE80::/10 and embedded the 2001 DB8, we would have this lawn-looking thing here that starts at the 10th bit and embeds the 2001 address in the 10th bit. The pros of this that there are no wasted bits, and you can embed prefixes up to /118. The cons is that it's not easy to read or parse. And when I say parse, I mean looking at the address and programmatically looking at the words of the 128-bit address. Another alternative is that we could use the prefix FE80::/16, and then we could embed the 2001 DB8 starting in the 17th bit so that it prints nicely. The pros are that it reads well and it can embed prefixes up to /112. Cons is that it wastes 6 bits of the leading 16 bits. Use cases and next steps. Use cases would be enterprise mobile devices like cell phones and tablets and so forth, aeronautical communications for airplanes to talk to air traffic controllers, unmanned air system networks for vehicle-to-vehicle communications, and home networks with multiple subnets such as HomeNet. I won't ask the 6 working question at this time, but I'd like to get some questions if we can fit them in the next minute.
Thank you, Fred. Any one comment or two on that? If not, then can you please send the blue sheets forward? We'll continue the discussion on the list, Fred. Thank you. We will, with regards to lease, comment on what we should do with the draft documents. I think we'll take that to the list. I think it's pretty clear that we'll keep addressing architecture parked. If anyone volunteers to do the changes necessary to privacy extensions, please let us know on the list. Yes, and then we have to work through the other ones. But I think apart from that, we'll talk on the list. Never mention the word 64 again on the list, or at least not for the next 3 months, please. And see you in Singapore.
Good. Thank you very much.
No, we can take them straight off the Etherpad. That would be lovely. Thanks, Barbara. Hey, don't eat it.
Okay, send us an email.